Good day, seniors. In this video lesson, we'll be having probability of union of events. So we have to take the union of events. We have to determine first whether the events are mutually exclusive and non-mutually exclusive. So two events are mutually exclusive if their intersection is empty. It only means that the two events have no common intersection. If A and B are mutually exclusive, then the probability of the union of the events A union B simply adding the two probabilities of A and B, PA plus PB. For any two events A and B which are not mutually exclusive, meaning they have a common intersection, the probability of the union of A and B is PA union B equals PA plus PB minus the intersection of A and B, the probability of that. Now to determine better, let's have this example. What's the probability of selecting a heart or a diamond from a deck of 52 cards? It's very obvious that the events are mutually exclusive. You cannot pick a card that is both a heart and a diamond at the same time. So basically, the probability of getting a heart H. Remember that when you see the word or, that means union, and then B, D for diamond. This is simply P of H plus P of D. So since there's no intersection, nothing will be subtracted. So what's the probability of getting heart? So there are 13 hearts in a deck of 52 cards. So it's 13 over 52 plus diamond. There are also 13 diamonds in a deck of 52 cards. So I give you 26 over 52. And that's 1/2. So this is for mutually exclusive event, a basic example. So have this. What's the probability of selecting a heart or a queen from a deck of 52 cards? Now in this case, the probability of getting a heart, or remember the word or again, is union. Then this time queen. So this is P of H plus P of Q. Since the events are not mutually exclusive, there is a card that is both a heart and a queen. And you know it's the queen of hearts. We should subtract that common intersection. So the intersection, the heart and queen. So heart, there are 13 cards, 13 hearts over 52. Queen, there are 4 queens in the deck. And subtracting that common intersection, the heart which is also queen or the queen of hearts, 1 over 52. So you will have here 13 plus 4, 17 minus 1, that is 16 over 52. Yes, that's it. And the answer here is simplifying by 4, 4 over 13. Okay, so now you know that the basic difference between not mutually exclusive and exclusive events. When you should subtract, there's a common intersection. So have this problem. A pair of dice is rolled once. What is the probability that the sum of the numbers rolled is either 5 or 11? So let the event A be the event that the sum of the results for the two dice is 5. Sum is 5, and let the event B be when the sum is 11. Okay, now you know that again this is a mutually exclusive event. You cannot have a sum that is both 5 and 11. It's just impossible. So anyway, the probability of the union A union B is simply the sum of the probabilities P of A plus P of B. And we can get a sum of 5 rolling a pair of dice when the results are 1 and 4. Of course, 4 and 1, 2 and 3, and 3 and 2. So there are only 4. Over the total possible outcomes when you prepare for enrolling a pair of dice. The first die will give you 6 outcomes. The second die will give you also 6 outcomes. So basic multiplication rule, 6 times 6. That's 36 in the denominator for the total outcomes. So this is the probability of getting a sum of 5. Getting a sum of 11, you can get that when you have 5, 6, 6, and 5, and that's it. So there are only 2. Again, over 36. So this would be 4 plus 2, 6 over 36. And simplifying, get 1/6 for this. Now, for the counterpart of this problem in not mutually exclusive events. So this is still not mutually exclusive. I erased that accidentally. A pair of dice rolled once. What's the probability that the sum of the numbers rolled is either a multiple of 3 or an even number? So again, represent event A as that which the result will be the sum is a multiple of 3. And then P of B, when the sum is even. Now, to get the event A, which is the result of having the sum of the dice multiple of 3, obviously, that's when the sum is 3, 6, 9, 10, 12. You can go 12 is the maximum here, obviously, because 6 is the maximum for each die. 6 plus 6 give you 12. Sum is even. It will happen when you have the sum of 2, 4, 6, 8, 10, and 12. Now, very obvious. You see this 2, 6, it's also in the other, and then 12, it's also in the other. So there is a common intersection for the two events. That is having a sum of 6 and 12 for the 2. Okay, so anyway, getting a sum of even is easy because the numbers 1 to 12 get a sum from 2, 4, 6, 8, 10, 12. Let's start here. So to get a sum of 2, that's obviously 1, 1 only. The result for the first die is 1, second is 1, and that's it. To get a sum of 4, get here 1, 3, 3, 1, and 2, 2. So there are only 2. To get the sum of 6, you have here 1, 5, 5, 1, 2, 4, 4, 2, and 3, 3. To get the sum of 8, you have 2 and 6, 6 and 2, 3 and 5, 5 and 3, and 4, 4. To get the sum of 10, it only happens when you have 4 and 6, 6 and 4, and 5, 5. To get the sum of 12, that only happens when you have 6 and 6. Okay, so basically to get the probability of B, let's count this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there are 18 and obviously 36 again for total outcomes. Now to get sum of a multiple of 3, obviously it will happen we have 1, 2, 1 first die, 2 in the second die, then 2, 1, and then sum of 6 you have 1, 5, 5, 1, 2, 4, 4, 2, then 3, 3. We have actually listed this already, it's here. So to get sum of 9, you have 4, 5, 5, 4. Almost forgot 3, 6, and 6, 3. And that's it. Set sum of 10. It's also, we should not have a 10 here. So it's only 3, 6, 9, 12. Sorry. To get a sum of 12, it's already here. So just write it here, 6, 6. So the probability of getting a sum that is a multiple of 3 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 over 36. Right? So remember that, let's erase, wait. To get the probability of the union, so I put it here at the top, probability of the union of the events, A union B, we should add A and then B. But we should not forget to subtract the intersection C, then B. There. So we have A, which is 12 over 36. b, which is 18 over 36. But we should subtract the common. That is these two, 6 and 12. So we have here, for 6, this one. So 1, 2, 3, 4, 5. There are 5 of them. And then 12. So 6 over 36. So the probability of having a multiple 3, sum that is a multiple 3 or an even sum is 12 plus 18. That's 30 minus 6, 24 over 36. Simplifying, the answer is 2/3. That's it. Let's have another example. Yeah, I listed all the sums, so wait. Okay, let's use that later. A number is selected at random from 1 to 3 to 20. What is the probability the number selected is neither divisible by 3 nor 5? Okay, now, because of that negation, we have to simplify first. Probability A, let the probability of A be that we pick the number that is divisible by 3. Divisible by 3. Let B be the event that we pick a number that is divisible by 5. And now, if we write here A union B, what is this is the probability of having a number that is divisible by 3. Divisible by 3 or 5. Don't forget the or is for the union. Okay, so to get this negation, neither divisible by 3 nor 5, that is basically the complement of this event, A union B complement. So the symbol here, the prime, means the complement of the event. And to illustrate the complement of an event, let's say P of A. Let's say P of A is the probability that it will rain. The probability that a team will lose a game. It's 1/3. So the complement of that event, the symbol is A prime, is the opposite of that. That's called the complement. So the probability, if A is the probability that a team will lose, then A prime must be the probability that a team will win. It's simply 2/3. So it's simply subtracting the probability from 1. So 1 minus 1/3, 1 minus P of A. So to show that P of A complement is 1 minus P of A. Right. Now going back to the question. We have here PA union B is the probability that the number is divisible by 3 or 5. And PA union B prime is the negation of this, the complement of this. So this will answer the question. Neither divisible by 3 nor 5. So we get here, it's simply 1 minus the probability of A union B. Right. Now here, we have this as a PA union B. Of course, this is PA plus PB minus the intersection of the two events, A intersection B. Now PA is how many numbers are divisible by 3 from 1 to 20? So we can basically count that. 3, 6, 9, 12, 15, and 18. So there are 6 of them. Of course, over 20 the total. P of B, number divisible by 5. So basically we can count it again. 5, 10, 15, and 20. So there are 4 of them over 20. But this here, the intersection of the events, the number that is both divisible by 3 and 5. So for intersection, the word is and. If union is for or, intersection is and. So the number that is both divisible by 3 and 5 must be 15. So it's only one number 20. So the answer here would be 6 plus 4, 10 minus 1, 9 over 20. Now to answer our problem, neither divisible by 3 nor 5, so we subtract this probability from 1. And the final answer here would be 11 over 20. So basically that's it. We run out of time. I have one problem more. Just show it to you. No, not one. This one. This is good. Just try to answer this. Right. Okay. Good day, seniors.